All right, let's take a look at our practice test. So we're told to solve each inequality. And so for problem number 1, we have the fourth root of 3x minus 1, and this is less than 2. So as we discussed in the lesson, the idea here is that we're going to work in the real number system for these types of problems, unless you're otherwise told by your teacher. So if you have something like a square root or fourth root or sixth root or some even root, then you have to be really careful that your radicand is non-negative. So in other words, I would take this 3x minus 1, which is my radicand. So let me just write that out there. And I would basically set it as greater than or equal to 0 to make sure that it's going to be non-negative. And so I would add 1 to both sides of the inequality. Let's cancel this away. Let's say that we have 3x is greater than or equal to 1. Let's divide both sides of the inequality by 3. Let's cancel this away. And so x needs to be greater than or equal to 1/3. So if we get something less than 1/3, we have to reject that. So let's go ahead and put this over here. Just put a little border, and I'll say that the domain for this guy is going to be, let me make this a little bit better. So the set of all x such that x is greater than or equal to 1/3. So we'll need to think about that as we're getting our solution going. And now let's think about how we can solve this inequality. So most of you would just raise both sides to the fourth power. I'm going to avoid doing that here, because when you square both sides of an inequality or you raise both sides to a fourth power or an even power, you're going to sometimes get issues. So to avoid those issues, I want to give you something that's consistent. And so I'm going to work with a related equation. You'll never have a problem if you do it this way. So we'll go ahead and say this is the fourth root of 3x minus 1, and we'll set that equal to 2. And I'm just going to solve this real quick. So basically, I would raise both sides to the fourth power. And so this would give me the radicand here. So this is 3x minus 1. And this equals 2 to the fourth power is 16. Very easy equation to solve. Let's add 1 to both sides. Let's cancel this. I'll just drag this over here and say 3x is going to be equal to 17. Let's divide both sides of the equation by 3. And I'll cancel this away and say x is equal to 17 thirds. I want you to recall that when you raise both sides of an equation to an even power, such as squaring or raising to the fourth power like we just did, you sometimes get extraneous solutions, so you always have to check to make sure it works. So if I plugged in a 17 over 3 there, what would I get? Well, 3 times 17 over 3 is 17. Then 17 minus 1 is 16, and the fourth root of 16 is 2, so this is a valid solution. Okay, so now that we have our domain and we have our solution for the related equation, what we're going to do is go to the number line, set up some intervals, and we're going to test in each interval. Let me just rewrite this inequality. So we have the fourth root of 3x minus 1. I'm going to subtract 2 away from each side, so then minus 2. This would be less than 0. All right, so coming to the number line, we're just going to split this up into 3 intervals. So we're going to first think about this critical value of 1/3. And this is not going to be exact because obviously our notches are in terms of integers. But let's just say that 1/3 is about right there. Let's just call that 1/3. And then we're also going to have this other guy, this critical value of 17 thirds. So that's basically 5 2/3. So let's just say that's about right here. Again, it's not going to be exact, but this is close enough. So let's say this is 17 thirds. Okay, so basically you have 3 intervals. So let's say this is interval A. So that's anything less than 1/3. So that's automatically going to be rejected because it violates the domain. Then you have B here, which is between 1/3 and 17 thirds. We need to test. And then we have C, which is greater than 17 thirds. So let me write out that we have A, we have B, and we have C. So we know already that for interval A, or you could say region A, it's automatic reject. So I'm just going to write false immediately. For interval B or region B, you just take a value, and it could be any value in that region, and basically plug it into the inequality, see if it's true. If it is, every number in that region is going to work. If it's false, then no number in that region is going to work. So I could just pick something like 1. I think that's easy to work with. And let's just see what we get. So we would have the fourth root of 3 times 1 is 3, and then 3 minus 1 would be 2. So the fourth root of 2 minus 2 is less than 0. Now, without pulling out my calculator, I know that the fourth root of 2 is going to be smaller than 2, right? And 2 is being subtracted away. So this right here on the left is going to be a negative value, okay? And a negative value is always less than 0, so this is going to be a true statement. So let's come back up here and just put true here. And then for region C, let's just pick 6. So we'll have the fourth root of 3 times 6 is 18. 18 minus 1 is 17, so the fourth root of 17. Then minus 2, and this should be less than 0. Now, again, without pulling out my calculator, I know that the fourth root of 16 is 2, and 2 minus 2 would be 0. So the fourth root of 17 is going to be larger than 2, So basically, this left-hand side here is going to be a positive value, and a positive is never less than 0. So this is going to be a false statement. So let's come back up here and say that this is false. Okay, so to form our solution, we would just start with region B. So we know that's between 1/3 and 17/3. So we would just say, let me just put this over here. I'll put a little border. We'll say that x is greater than 1/3 and less than 17/3. And now I want to consider these endpoints or critical values or boundaries or whatever you want to call them. So thinking about 1/3, would that work? Well, I know anything in region B works, right? So anything to the left of 17/3. Well, that would actually include this 1/3 here because it does not violate the domain. X is allowed to be 1/3, right? It just can't be anything less. So we would say that this is included, right? So I'll put this as a less than or equal to here. Now, in terms of 17/3, that's going to be excluded. And the reason is simple. This right here is a strict inequality, right? It is strictly less than. If I plug in a 17/3 for x, what's going to happen is the left side would be equal to the right side. So you'd have a 0 over here and a 0 over here, and 0 is not less than 0, so 17/3 needs to be excluded. So this would be our solution. And let's just go through and write this in interval notation. So I'll have a bracket and then a 1/3, and then a comma, and then a 17/3, and then I'll put a parenthesis there. So again, 1/3 is included, that's why we have the bracket. 17/3 is not included, that's why we have the parenthesis there. And then let me put my notches back in here so we can do a graph. So for 1/3, we said that was about right here. Let's just say that's 1/3. And then for 17/3, again, that's 5 2/3. So let's just say that's about right there. So this is 17/3. And basically, you want to put a bracket at 1/3, or you could put a filled in circle. Some books do that. And you want to put a parenthesis here at 17/3, or some books would use an open circle. Okay, either one you can use. So then we would shade everything in between here, just saying that x can be 1/3 and any number going up to and excluding 17/3. All right, let's take a look at problem number 2 now. So we have x minus 2 is less than or equal to, we have the square root of 2x plus 20. So again, the first thing I'm going to do here is figure out what is my domain. If I'm working with the real number system, then this guy right here, this 2x plus 20, the radicand, it needs to be non-negative. So let's say that 2x plus 20 needs to be greater than or equal to 0. Let's subtract 20 away from each side of the inequality. Let's cancel this away. We'll have 2x is greater than or equal to negative 20. Let's finish this up by dividing both sides of the inequality by 2. And then we'll cancel this away, and we'll say that basically x is greater than or equal to, we have negative 20 over 2, which is going to be negative 10. So let's say that our domain for this guy would be the set of all x such that, again, we'll just have this condition that x is greater than or equal to negative 10. So it can be negative 10, but it just can't be anything less than that. Okay, from here, what I'm going to do is solve the related equation. So we'll say that x minus 2 is equal to the square root of 2x plus 20. So because this square root is isolated on the right-hand side, I can just immediately square both sides. The main thing here is to not forget your formula. You can't just say this is x squared minus 2 squared. You have to expand it and say this is x squared minus 2 times this guy times this guy. So basically 2 times 2 is 4, then times x, then plus this guy squared, so 2 squared is 4. And this equals, here we would just have the radicand, so the 2x plus 20. All right, I'm going to put this in standard form and then see if I can factor it or use the quadratic formula if I have to. So I'm just going to subtract 2x away from each side of the equation. Let's cancel that. Subtract 20 away from each side of the equation. Cancel that. So this side is 0. Let's say that we have x squared, and then negative 4x minus 2x would be negative 6x. Then 4 minus 20 is going to be minus 16, and this equals 0. So this will be something we can solve using factoring. Again, you can always use the quadratic formula if that's what you prefer. So I'm going to put an x here and an x here. I need two integers whose sum is negative 6 and whose product is negative 16. Well, that's going to be negative 8 and positive 2. So we'll say x minus 8 is equal to 0. Here we would add 8 to both sides, so x is equal to 8. Then basically, or you have x plus 2 is equal to 0. Here we would subtract 2 away from each side, so x could be negative 2. So let's put this like this. Now, because we squared both sides of this equation, again, you have to check for extraneous solutions. So these are our proposed solutions. So let's check them and make sure that they work. All right, let's start by checking 8. So over here on the left, you'd have 8 minus 2, which is going to be 6. And this should be equal to, if you plugged in an 8 here, 2 times 8 is 16. 16 plus 20 is 36, and the principal square root of 36 is 6. So this one works as a solution. The next one is going to be rejected. It's going to be an extraneous solution. So negative 2 minus 2 is negative 4. We're saying this is equal to, if you have 2 times negative 2, that's negative 4. Negative 4 plus 20 is 16, and the principal square root of 16 is going to be 4. So this is a false statement. So that's why we reject this x equals negative 2. So coming back up here, I'll just put x equals 8. That's going to be for our boundary. And then let me just copy this. So x minus 2 is less than or equal to the square root of 2x plus 20. Okay, so let's think about the intervals we can set up here. So for one, we need to consider that anything less than negative 10 would be rejected. So let's go over here and make a notch for negative 10. And so I'm just going to say that anything that's less than that, let's just call that region A, that's automatically going to get rejected because it violates the domain. I'll just go ahead and put false right now. Then the other critical value is at 8, so let's put a line right there. So region B would be between negative 10 and 8, and we need a test there. And then region C would be anything that's greater than 8, and we need a test there. So for region B, I would just pick 0, something you can just do mentally most of the time. So if I plugged in a 0 there, I would have negative 2 over here. This would be less than or equal to, 2 times 0 is 0, so you just have square root of 20. Now the square root of 20, you could break that down into 2 times square root of 5. But that's not really relevant because this side's positive and this side's negative. So you don't even need to punch this into your calculator because you know that a positive value here is going to be greater than a negative value here. So this is going to be true. Now in region C, you could just pick something like 9, and you're going to see that this doesn't work. I'm just going to write false for right now, save a little time. But let's just plug this in and see what we get just to prove it to you. So 9 minus 2 would be 7. And this would be less than or equal to 2 times 9 is 18, and then 18 plus 20 is going to be 38. So this would be the square root of 38 here. Now again, without pulling out a calculator, you can tell that this side right here is not going to be greater than this side right here, and they're certainly not going to be equal. Think about the fact that the square root of 36 would be 6, right? This is a little bit more than that, but it's not going to quite be 7 because the square root of 49 would be 7, right? So this is obviously going to be smaller than 7. Again, you can use your calculator if you need to. If you punch that in, you get about 6.16. But again, without using it, you can immediately tell that this is going to be a false statement. So what we can conclude is that things in region B are going to work. So I would say that x is going to be greater than this negative 10 and less than this positive 8. Now, we think about negative 10 and 8 separately. Now, anything in region B, meaning less than 8, works. Again, this is going to go down to and include this negative 10 because that's in our domain, right? We just can't go less than negative 10. So this would be a less than or equal to. Negative 10 would be included. Then in terms of 8, it solves the related equation. So this side would be equal to this side. And here we have a non-strict inequality. We have that or equal to part. So this would be included as well. So x here would be greater than or equal to negative 10 and less than or equal to 8. All right, so let's put this in interval notation. I'll just put a bracket next to negative 10, then a comma, then I'll put 8, and then I'll put a bracket. And so coming to the number line, again, I can just put a little notch here for negative 10, and we're going to just basically use a bracket in each case. So I'll put a bracket there, and then over at 8, I'll put a bracket there. And again, you can use a filled in circle if that's what you prefer. And then I'm just going to shade everything in between. So x here can be negative 10, and then any value going up to and including positive 8. All right, let's look at problem number 3 now. So we have the square root of 10 minus x is greater than x minus 8. And again, I'm going to figure out what is my domain. So I'm going to say that 10 minus x, which is my radicand here, needs to be non-negative, so it needs to be greater than or equal to 0. For this one, you could just add x to both sides of the inequality and basically say that 10 is greater than or equal to x, or you could flip that around and say x is less than or equal to 10. So let's write out our domain just so we have it. We'll say that the domain is going to be the set of all x such that x is less than or equal to 10. Close that down. And now let's think about solving the related equation. So we're going to have the square root of 10 minus x. This would be equal to x minus 8. Okay, so just like in the last problem, we can immediately square both sides. This square root is isolated on the left. So I can just square this side, and then I can square this side. So on the left, I just get the radicand. So I'm just going to get this 10 minus x. Then this equals. Over here, make sure to use your formula. So this is x squared. Then minus 2 times this guy times this guy. So 2 times 8 is 16. and then times x, and then plus this last guy, which is 8 being squared, so that's 64. Okay, so a simple quadratic to solve, something, again, you're going to be able to factor. So I'm going to add x to both sides of the equation. Let's cancel this away. Let's subtract 10 away from each side of the equation. Let's cancel this away. So this side is 0. So we'll basically say I'm going to flip this around because I like my variable on the left. So I'll say this is x squared, and then negative 16 plus 1 basically would be negative 15. So this is minus 15x. And then 64 minus 10 would be 54, so plus 54. And this equals 0. Okay, so the left side, very easy to factor this. We'll go ahead and say that this is x and this is x. I need two integers that sum to negative 15 and give me a product of positive 54. So that's going to be negative 6 and negative 9. So negative 6 and then negative 9. So here, again, you can solve x minus 6 is equal to 0 or x minus 9 is equal to 0. In this case, you would add 6 to both sides. So you would say this is x is equal to 6. Here, you would add 9 to both sides. So you would say x is equal to 9. So again, these are proposed solutions, so we do need to check them. Okay, so let's start by checking 6. So you can see that it doesn't work. You're going to eyeball that and see 6 minus 8 is negative 2. So this is, you can reject that immediately, or you can go through the whole thing. So 10 minus 6 is 4. The square root of 4 is 2. Is this equal to 6 minus 8 is negative 2? No, this is false. So that's why 6 got rejected. For 9, you can see that's going to work, right? 10 minus 9 is 1. Take the square root of 1, you get 1. And this is equal to 9 minus 8 is 1. So this 9 is good to go. So coming back up, I'll just say x is equal to 9. And let's just rewrite this real quick. So we have the square root of 10 minus x. And this is going to be greater than x minus 8. So coming to the number line, you're going to have two critical values. You have 9 and then you have 10. So let's put a little border here at 9. And then for 10, we really don't have a notch. So let's just put that right there and just say that's 10. Doesn't have to be perfect. So we'll just go ahead and put a vertical line there. So this is going to be a little bit tight, but basically region A is going to be anything that's less than 9. So this is my region A. Then region B, that's our tight window. That is between 9 and 10. And then for region C, this is going to be an automatic reject for us because, again, it violates the domain. X here needs to be less than or equal to 10. So it can be 10, but it cannot be larger. So let me put false here. This is automatically going to be rejected. So then let's test something in A and see if it works. You could pick anything you want. I think I would pick 0 because it's nice to work with. So 10 minus 0 would be 10. So this would be the square root of 10. Is this greater than, if you plugged in a 0 here, 0 minus 8 would be negative 8. Well, yeah, the square root of 10 is positive. We don't need a calculator for that. And that's going to be greater than this negative 8, right? Positive is always greater than a negative. So for region A, we'll say this is true. Now for region B, let's just pick something like, let's say 9.5. Again, this is going to be a really tight window. So we'll pick something like that. So we'll say the square root of 10 minus 9.5 is 0.5. And then is this greater than 9.5 minus 8? That's going to be 1.5. Now, I think that most of you know without pulling out your calculator that this side over here is not going to be greater than this side over here. But again, if you want to punch it in, you're going to get about 0.71. Okay, so 0.71 is not greater than 1.5. So this is going to be false. Okay, so thinking about our solution, we know that anything less than 9 is going to work. So x is less than 9. Now, will 9 itself work? No, because that solves a related equation. And if you think about it, this is a strict inequality, right? So this is a strictly greater than here. So 9 itself will not work. And of course, 10 will not work because it's on the other side, right? So we're not even going to consider that here. So in this case, we could just say x is less than 9 and we're good to go. So in interval notation, I'll put negative infinity here next to a parenthesis, and then comma, I'll put a 9 here next to a parenthesis because again, it's not included. And then graphically, I'm going to find 9 on the number line. Let's put a parenthesis there facing to the left. Again, if you want to use an open circle, that's up to you. And then I will shade everything here going to the left like this. So that's my solution graphically. All right, let's take a look at problem number 4. So here we have the square root of x squared minus 8x minus 33. This is less than or equal to x plus 10. So I'll just tell you in advance, this one's extremely tedious. So let's just go through it. Just like we've been talking about in the real number system, if you have a square root, well then your radicand needs to be non-negative. So here we have a quadratic as the radicand. So this is what makes this problem a little bit more tedious. So we have x squared minus 8x minus 33. That is greater than or equal to 0. So this is something we're going to solve as a quadratic inequality. So again, to do this, you would first replace this inequality symbol with equals. So you would say x squared minus 8x minus 33 is equal to 0. you're going to find your critical values, and then you're going to test. So let's go ahead and factor this left-hand side here. So we know that this is x and this is x. And then for two integers that sum to -8 and give me a product of -33, well, that's going to be -11 and +3. So -11 and +3. So basically we know that here you would have x minus 11 is equal to 0, then or x plus 3 is equal to 0. So x is going to be, we add 11 to both sides here, so you would get x equals 11. Then over here, you would subtract 3 away from each side, so x is also -3. So what we're going to do now is come to the number line, and again, we're just going to test. For the critical values, you're going to have -3, and then you're also going to have 11. Now, I don't have a notch for that, so let's just say 10 is maybe right here, and let's just extend this out a little bit like this, and we'll say that 11 is right here. So let me put that like this. And then essentially, I'm going to have 3 intervals. So this is region A, or you could say interval A, then B, then C. So let's say this is A, B, and C. Now, I'm going to test inside of A, and you could pick something like, let's say -4, and see if that works. It's probably better to put this into factored form. I think that's a little bit easier. So let's put this back like this, and see that we have x here and x here. Remember, you had -11 and then +3. So if I plug in a -4, you'd have -4 minus 11, which would be -15. And then here you'd have -4 plus 3, which would be -1. So basically -15 times -1. Now, we know that's 15, but again, you could just think about the sign. We know that this would be positive, and a positive is always greater than 0. Okay, so A will work. So we'll say that this is true. Now, I'm just going to tell you in advance that B is not going to work. We'll just say this is false. But again, we can obviously prove this by just picking something like 0, and that's really easy to work with. If you plug in a 0, here you'd have -11, and here you'd have +3. Again, without going through and saying that's -33, you could just think about the fact that it's going to be negative, and a negative is not greater than 0, and it's certainly not equal to 0, so that's why it's false. Then for C, it's going to work again, so let's just say this is true. You could pick something like, let's say 12. So 12 minus 11 would be 1, and then over here, 12 plus 3 would be 15. So again, you just need to think about the fact that it's positive, and a positive is always greater than 0, so this would be true. So let's erase this. Now for writing the solution, we know anything in A will work, and then anything in C will work. So x is going to be less than -3, then or x is going to be greater than 11, and then because we have this non-strict inequality, this or equal to part here, then both of those guys are going to work. So the -3 would work, and so would the 11. So let's adjust our answer and say x is less than or equal to -3, or x is greater than or equal to 11. So coming back up here, let's just write out our domain. So we'll say that it's the set of all x such that, and then we're just going to drag this up here. So basically like that. So we would say that x is less than or equal to -3, or x is greater than or equal to 11. And then from here, all we have to do is go in and solve the resulting equation. And again, we're going to set up our intervals and then just test. So let's say that now we have the square root of x squared minus 8x minus 33, and this will be equal to x plus 10. Now this square root is isolated on the left, so I'm just going to square both sides immediately. And so this radicand here is what we would get. So we would have the x squared minus 8x minus 33. This equals, over here, you have to use your formula. So x squared plus 2 times x times 10, which is going to be 20x, then plus 10 squared is 100. So notice that you have x squared here and x squared here. You could subtract x squared away from each side of the equation, and those would go away. I'm going to subtract 20x away from each side of the equation. Let's cancel that. Let's add 33 to both sides of the equation. Let's cancel that. So what I'll have here is -28x is equal to 133. Let's divide both sides of the equation by -28. And let's see what that gives us. So this would cancel. We'll have x is equal to, we know this is negative. For 133, it's basically 19 times 7. And we know that 28 is going to be 4 times 7. So let's cancel this common factor of 7, and we'll say that x is going to be equal to -19 over 4. All right, so let's check this. I'm going to convert this into a decimal so that I don't have to get all these fractions. It's going to take forever. So it's -4.75. So over here, if I plugged in a -4.75 and I added that to 10, I would get 5.25. So over here, let's take the square root of -4.75 squared is 22.5625. And then negative 8 times negative 4.75, that's going to be 38. So you would have 22.5625 plus 38, and that's going to give you 60.5625. Then subtract away 33. You're going to get 27.5625. So let me write that here. So the square root of 27.5625. And then I'm going to hit the square root key, and you're going to get this 5.25. So 5.25 is equal to 5.25. So this is a valid solution. So x equals negative 19 over 4. Let's write this out. So x equals negative 19 over 4. Or again, you could write negative 4.75 if that's easier for you. So let's copy this. We have the square root of x squared minus 8x minus 33. And this is less than or equal to your x plus 10. All right, so coming to the number line, you're going to have 4 intervals. Let's start with negative 19 over 4, which again is negative 4.75. Let's just say that's about right there. So this is negative 19 over 4. And make that 9 a little bit better there. And then the next one is negative 3. So let's put that right there. Then you're also going to have 11. So let's just say this is 10 right here. And let's just extend this out like this. And let's just say this is 11 right here. So I'll just put my line down here like this. So let's just say this is A. That's going to be anything less than negative 19 fourths. This is B. That's going to be between negative 19 fourths and negative 3. And then you're going to have C, which is between negative 3 and 11. And then D is going to be greater than 11. Now, we said for the domain that x needs to be less than or equal to negative 3, or x could be greater than or equal to 11. So that tells me that region C is an automatic reject zone. So we're going to go A, B, and I'll probably have to put this over here. So C and D. Let's put this as false. This is going to be automatically rejected. Okay, so let's test inside of A, B, and D and see what works. So for A, you could pick something like, let's say, negative 5. So plugging in a negative 5, you would have negative 5 squared. Then you'd have negative 8 times negative 5, and then minus 33. We know this is 25, and then we know this is 40. So basically, you would have 25 plus 40, which is 65, and then minus 33. That's going to be 32. So this is the square root of 32. Now, 32 is 16 times 2, so the square root of 16 is 4. So this is 4 times square root of 2. So this is 4 times square root of 2. So this is less than or equal to, over here, negative 5 plus 10 is going to be 5. So is this a true statement or is this a false statement? Well, 4 times square root of 2, if you did that on your calculator, is about 5.66, and that is not less than 5, and it's certainly not equal to 5, so this is false. So things in region A are not going to work. So let's say that this is false. Now, let's check something in B. This is a tight window, so I'm just going to pick negative 4, just to make it easy. So let's say the square root of negative 4 being squared. Then you have your negative 8 times negative 4, then minus 33. And then over here, this is less than or equal to, negative 4 plus 10 is going to be positive 6. So negative 4 squared is 16, so we know that. And then basically negative 8 times negative 4 is plus 32. So we know that 32 minus 33, that's going to be negative 1. So this would be minus 1, and 16 minus 1 would be 15. So this is the square root of 15. Now you can punch that into your calculator. It's going to be about 3.87. But you could just eyeball that and see that this is going to be less because, again, the square root of 36 would be 6, right? So that would be the point where they're equal. This is the square root of 15, so obviously it's going to be less. So this is a true statement. So for B, we'll say this is true. And then what about D? So D is anything that's greater than 11. So let's check 12. So here, let's go the square root of, you'd have 12 squared, which is 144. And then basically negative 8 times 12, that's negative 96. So let's go minus 96 and then minus 33. Let's punch this into the calculator. 144 minus 96 is 48. And then 48 minus 33, that's going to be 15. So this is the square root of 15 again. And this is less than or equal to, here if you plug in a 12, 12 plus 10 is going to be 22. So obviously the square root of 15, which again is about 3.87, is going to be less than 22. So we'll come back up here and just say that this is true. Now let's carefully think about our solution. This one's a little bit hard. So basically we want B and we want D. So B is basically where x is greater than negative 19 fourths and less than negative 3. Then we're going to put or here. We want D, so that's x is greater than 11. Now, we need to consider all these boundaries or critical values or endpoints or whatever you want to call them. So would negative 19/4 be included? Yes, because remember, this solves the related equation, okay? So this is going to be included because this is a non-strict inequality here. We have less than or equal to. Now let's think about negative 3 and 11. Remember, if I plug in a negative 3 or an 11, this radicand here is going to be 0, right? So this side right here would be 0. And again, you could just think about this over here. If I had a negative 3, well, obviously this would be positive. So this 0 is going to be less than this positive. So this does work. Then the other one is 11. Again, you can just think about this. This is going to be 0. If you put an 11 here, that's positive. So 0 is going to be less than this positive. So this would work as well. So this would be the full solution here. So for interval notation, let's just say we have a bracket. So negative 19/4. And then comma negative 3. We have a bracket. And then it's the union with, you have 11 next to a bracket. And this goes out to positive infinity. Again, you always use a parenthesis with infinity. So graphically, let me put in my notch again for this negative 19/4. And then we have our negative 3. So let me just put a bracket here. And let's put a bracket here. We'll shade everything in between. Again, if you want to use a filled in circle in each case there, that's up to you. And then for 11, again, we don't have it. So let's just say this is 10. Let me just extend this out a little bit and say this is 11. And then basically, I'm just going to put a bracket here at 11, or again, a filled in circle, and then just shade everything to the right, including that arrow. So basically, x here can be any value that's including negative 19/4 going up to and including negative 3. Then, or it could also be starting at 11 and including 11 going out to positive infinity. All right, let's take a look at problem number 5 now. So we have the cube root of 3x plus 2 is greater than or equal to 3x minus 4. And so with this guy, you have this cube root, right? So it's an odd index here. And so you can take the cube root of a negative number in the real number system. So when you think about your domain, it's just the set of real numbers. So you can basically skip the step where you take your radicand and say it's greater than or equal to 0. It's not needed here. So I'm just going to say that the cube root of 3x plus 2 is equal to 3x minus 4. I'm going to get the boundary, and then I'm going to test on each side. So for this one, I'm just going to cube both sides. And this is going to rely on our formula. So hopefully you remember that. Over here, I just get the radicand. So this is 3x plus 2 is equal to, you're going to cube this first guy. So 3x being cubed, that's going to be 27, which is a result of 3 being cubed, and then times x cubed. And then basically, you're going to have a minus here, and it's 3 multiplied by this first guy squared. So 3 squared is 9, and then x squared, and then times this guy, which is 4. So putting that together, 3 times 9 is 27. 27 times 4 is 108. So basically, this is minus 108x squared. And then basically, the next guy is a plus. You have 3 times this guy, which is 3x, times this guy, which is 4 being squared, which is 16. So 3 times 3 is 9. 9 times 16 is 144. So let's put plus 144x. Let me actually slide this down just a little bit so it fits. And then lastly, you have a minus again. You're going to cube this guy. So 4 cubed is 64. All right, so what I'm going to do now is subtract 2 away from each side. Let's cancel this. And subtract 3x away from each side. So let's cancel this. This is 0 now. And I'm going to flip the sides like I always do. So I'm going to say this is 27x cubed. And then minus 108x squared. Let me erase this and make this a little bit better. And then 144 minus 3 is 141. So this is plus 141x. And then basically negative 64 minus 2 is negative 66. And this will be equal to 0. Now, in this course, at this point, we have not talked about how to factor something like this. This is something where you need the rational roots test. So we haven't gotten there yet. So I'm just going to give you the factorization so we can solve this problem. But later on in the course, we'll talk about how to factor a polynomial that basically has a degree of 3 or higher. So I'm going to pull out a 3. And then I'll have this x minus 2, this quantity, times the quantity 9x squared, and then minus 18x, and then plus 11. This will be equal to 0. To make this simpler, you could divide both sides by 3. And so that would just give you this x minus 2. That quantity times the quantity 9x squared minus 18x plus 11. This would be equal to 0. Now we know that we would say x minus 2 is equal to 0. Then or 9x squared minus 18x plus 11 is equal to 0. Now I'm not going to waste your time with this one over here. You can do this on your own if you want. But essentially you're going to see that your discriminant is negative. Okay, so you're going to get two non-real complex solutions, and we're working with real numbers here. So we're going to exclude these. We don't need them in this case. We're just going to work with this one, where basically the solution is x is equal to 2. So this is all we need. These can be excluded again because they're non-real complex solutions. So x equals 2 is what we're looking for. So let's just copy this real quick. We have the cube root of 3x plus 2. This should be greater than or equal to 3x minus 4. So coming here, I'll just put a line at 2. You're just going to have two intervals here, so a and then b. So region A and then region B. So nothing to automatically reject here because, again, we're working with a cube root, so the domain is a set of real numbers. So what I would do is just pick something in A. Looks like 0 is available, so that's going to be pretty easy to work with. So you plug in a 0 for x, you basically get the cube root of 2. So the cube root of 2 is greater than or equal to. Plug in a 0 there, you get negative 4. Now, a positive is always greater than a negative, so you don't even need to know what the cube root of 2 is. So this is going to be true. Now, for B, you could pick something like, let's say 3. It doesn't really matter. So 3 times 3 is 9. 9 plus 2 is 11. So you'd have the cube root. So the cube root of 11 is greater than or equal to. So 3 times 3 is 9, and 9 minus 4 would be 5. Now, you could use your calculator for this, but I don't think you need it. So you could approximate this and say it's about 2.22. So that's clearly not greater than 5. But if you didn't want to use a calculator, remember the cube root of 125 would be equal to 5, right? So this is the cube root of 11, so obviously it's going to be smaller. So this we would mark as false. So a real easy solution to get here. So basically we would say that x is going to be less than 2, and then because this is a non-strict inequality, we would put the less than or equal to symbol there because 2 would be included, right? So x is less than or equal to 2. So we'll say that we have from negative infinity up to 2. Let's put a bracket there next to 2. And then again, I will go ahead and put a bracket at 2 facing to the left. If you want to use a filled in circle, again, that's up to you. And then I'll shade everything to the left like this. So basically x can be 2 or any value going down to negative infinity.